My name is Saswat Nayak, and I'm a PhD student at the Transportation System Research Laboratory at the University of California, Riverside. My main research focus is on vehicle positioning, multi-sensor fusion, and connected and automated vehicle applications. The project aligns with the CARNATIONS research goal of toughening, augmenting, and protecting the positioning and navigation aspect of connected and automated vehicle applications. The primary goal of this project is to design a virtual digital twin of a real-world intersection that will allow us to test and validate different positioning solutions for vehicle navigation. Currently, we have designed a virtual map of a real-world intersection in a simulation environment. It stores information such as the road geometry from the real-world intersection, sensor information from both the infrastructure and the onboard vehicle. So it allows us to leverage on a lot of information that we can use for improving the positioning requirements for the vehicles. Apart from the positioning accuracy, the integrity is also a crucial part of vehicle navigation. So when there is a degradation in vehicle navigation or the positioning performance, we can issue an alert to the human driver so that it can take control of the vehicle. For that, we have also introduced the human in the loop or the driver in the loop setup with our simulation environment. This research project aligns with the US DOT's goal of enhancing road safety by designing safety management systems and driver assistant technologies. We will investigate the impact of positioning uncertainty on the feasibility of a connected and automated vehicle application. Measurement errors and cybersecurity risk can jeopardize a CAV application's performance. That's why we will be leveraging on additional or external information such as vehicle-to-infrastructure communication and vehicle-to-vehicle communication for improving the vehicle positioning. This approach will help us dynamically adjust settings so that it can suit or meet the requirements of a CAV application. The purpose of the simulation studies are not to replace the real-world testing but to augment it. In the simulation environment, we can get realistic surroundings, road agents, and even the deployment of the sensors. Simulation studies will play an essential role in safe and cost-effective deployment of connected and automated vehicle applications. These simulation studies can serve as a proving ground where the innovative concepts can be tested, validated, and scaled for future deployment on roads. For a demonstration, we have designed an experiment at the virtual intersection. So it's a red light violation experiment where there is an ego vehicle which has the right of way and it is going straight. Meanwhile, an adversarial vehicle violates the signal and attempts to cross, creating a potential for a T-bone collision, especially if the ego vehicle's view is obstructed by side vehicles. The primary objective of this experiment is to note the driver's reaction, to observe if the driver is able to take preemptive actions and stop the vehicle before the collision happens. The long-term goal of this experiment could be to explore how vehicular and infrastructure sensor data could be leveraged to enhance situational awareness and provide timely alerts to the driver.